Section 3.1, States of Matter. States of matter are the phases: gas, liquid, and solid. Solid, as you can see, has very close particles. They are packed in very tightly. They don't move, but they vibrate back and forth very slightly. They cannot switch places because they are in a permanent spot, and there's a definite shape to a solid. Also a definite volume. There's also a pattern to how the particles come together, so it's always the same, and you can see in this case here that these particles are stacked right on top of each other, and they're very geometric, with one fitting in between 4 different ones over here on that side. Liquids are a little bit different. The particles are very close together. They touch, but they are not packed in like in a solid. They're free to move past each other so they can flow back and forth. And they are slightly compressible, but as any of you may know, if you've ever done a belly flop off the diving board, when you hit water, it is not very compressible, and it usually ends up hurting you because the water does not compress. There's a definite volume. So for example, if you have a gallon of milk, it's going to be a gallon of milk. It doesn't matter if it's in the container or if you pour it on the floor, that gallon of milk is still going to have the same volume of 1 gallon. There is not a definite shape though. So if we have a gallon of milk in the container, it's going to take the shape of that container. If we have a gallon of milk that we pour on the floor, it's just going to spread out into a huge puddle and have a very different shape. Gas, particles are very, very spread out. They're very random. They move all the time, very rapidly, and they are highly compressible. So you can take gas particles from a huge container and compress them into a very small container. They do not have a definite volume. They just kind of spread out and fill up wherever they are. They just want those particles to be as far apart from each other as possible, and so there's no definite shape for a gas either. So those are the 3 states of matter and how they relate to each other. Changes in state are when we change from a solid to a liquid, from a liquid to a gas to a liquid, from a liquid to a solid, or from a solid all the way to a gas, or a gas all the way to a solid. And you've heard of melting, freezing, boiling, or evaporating, condensation. You may have never heard of sublimation before, going from a solid to a gas. This you don't see very often. Most common one that you've probably seen is dry ice, where it makes smoke. It's going from that solid state of, it looks just like a white piece of snow, and then it evaporates directly into a gas and becomes that smoky looking gas. Deposition, the easiest way to describe this is probably snowing. There's gas up in the clouds, it condenses to a solid and becomes snow. Okay, you can see here that from a solid to a gas we have an increase in how much motion we have. So typically what causes that is temperature increase. Freezing point is the same as melting point, and that can be kind of confusing, but if you think about it, things freeze at 0 degrees Celsius and they begin to melt at 0 degrees Celsius. So those are the same temperature. Boiling point is the same as condensation point. So boiling of water is at 100 degrees Celsius, and when it starts to condensate, it's at 100 degrees. Okay, they just go in opposite directions. So freezing goes from 0 to colder, melting goes from 0 to warmer. Boiling goes from 100 to warmer, condensation starts at 100 and goes colder. So what's in between particles? When we see this gas here on the screen, what's in between those gas particles? Don't say air, because no, the particles are what make up the air. So what is in between each one of those particles? Nothing. And that's hard to understand because it seems like there should always be something there. But our particles are our matter. What's between the matter is nothing. So remember that when we have a gas, sometimes there's nothing between those particles.